Hi everyone, I am Swetha, Assistant Professor from the Department of Artificial Intelligence and Data Science at Vailtech Multitech Dr. Rangarajan Dr. Shakuntala Engineering College. Today I am going to take a topic on Introduction to Data Science. Let's move on to the presentation. First, we are going to see what is data science. Data science means collecting, cleaning, analyzing, and interpreting data to find hidden patterns and useful information. It is a combination of different subjects like mathematics, statistics, computer science, and domain knowledge. A data scientist uses different tools and programming languages to study data and solve problems. Next is data science process. Data science mainly works in several stages. The first stage is data collection. Data can come from many sources such as websites, sensor, mobile apps, survey, and database. For example, a shopping app collects user purchase data or a hospital collect patient's record. The second one is data cleaning. The collected data may have missing values, duplicate records, or errors. So before analysis, the data must be cleaned to make it accurate and reliable. The third stage is data analysis. In this step, various mathematical and statistical techniques are applied to understand the data. Analysts use methods like average, correlation, regression, and data visualization to identify patterns and trends. The next step is model building, where data scientists use machine learning algorithms to make predictions. For example, predicting product demand, detecting disease, or recommending videos on YouTube. After building the model, the results are represented through data visualization. Visualization helps to display information in the form of graphs, charts, and dashboards so that people can easily understand and make decisions. Next is applications of data science. Data science is widely used in almost every field today. It helps people and organizations make better decisions using data. In healthcare, data science is used for disease prediction, diagnosis, and treatment planning. By analyzing patient records, doctors can easily identify disease early and suggest better medicines. In banking and finance, it is used for fraud detection and risk management. Machine learning algorithms checks for unusual activities in transactions and prevent online frauds. In transportations, data science helps in traffic management and route optimization. Using sensors and GPS data, it predicts traffic flow and helps reduce congestion. In business and marketing, data science supports sales forecasting, customer analysis, and product recommendation. Companies like Amazon and Netflix use data science to recommend products or shows based on user preference. In weather forecasting, it analyzes large amount of climate data to predict rainfall temperature changes accurately. In stock market, data science helps in stock analysis and investment planning by predicting market trends. In education, it is used for student performance analysis and personalized learning. Teachers can track progress and improve teaching methods. In social media, data science powers sentiment analysis, helping companies understand people's opinions about products or events. Next is importance of data science. The main importance of data science is that it converts raw data into useful information. Companies use it to understand their customers, improve products, and plan business strategies. For example, online platforms like Amazon or Netflix analyze user data to recommend product or movies that people may like. Data science also plays a big role in future prediction. Using machine learning and AI algorithms, it can predict sales, weather, or even crime patterns. This helps organization plan effectively. The third one is automation and innovation. It is also important for automation and innovation. Many smart technologies such as self-driving cars, chatbots, and virtual assistants are built using data science principles. Governments also use data science to improve public services, healthcare system, and disaster management. Data science is important because it helps in decision making, efficiency improvement, and problem solving across all the fields. It connects data, technology, and human intelligence to create smarter solutions for everyday life. And the fourth one is better decision making. The major benefits is data science is better decision making. By analyzing large amount of data, organization can understand what is happening, why it is happening, and what may happen in the future. This helps them plan effectively and take correct actions. The final one is improved business performance. Companies use data science to study customer behavior, market trends, and product performance. This helps in increasing sales, reducing cost, and improving customer satisfaction. For example, e-commerce sites like Amazon use data science to recommend products customer based on their interest. Next is setting the research goal. Setting the research goal is the first and most important step in any data science project. It defines what problem we want to solve and what we want to achieve through data analysis. Without a clear goal, the entire project can become confusing and directionless. In this step, data science, data scientists or researchers work with domain experts, managers, or clients to understand the main objective. They discuss questions like what problems are we are trying to solve, why it is important, what type of data is needed, and what results are expected. For example, in a retail company, the research goal might be to predict which product customers will buy next month. In healthcare, the goal might be to detect early signs of diabetics from patients' data. These goals helps guide the project into the right direction. Next is SMART goals. Once the goal is set, it should be a specific, measurable, achievable, relevant, and time bound. First one is specific. Specific is nothing but the goal should be clear and well defined. It should answer what, why, and how. The second thing is measurable. Measurable in the sense you should be able to measure progress or success using numbers or results. The third one is achievable. Achievable is nothing but the goal must be realistic and possible to complete with the available time, data, and resources. Fourth one is relevant. The goal should be meaningful and connected to the main purpose or business need. The final one is time bound. Every goal should have a deadline or timeline to maintain focus and progress. This means the goal must be clear, realistic, and possible to evaluate within a given time. After defining the goal, the data science teams plan how to collect the right data, what tools to use, and what techniques are suitable for solving the problem. Next is retrieving the data. Retrieving the data is an important step in the data science process. It means collecting or extracting data from different sources for analysis. Data is the foundation of every data science project, and retrieving it correctly ensures accurate results. Data can come from many sources such as database, websites, sensors, social media, surveys, or files. Depending on the project goal, data scientists choose the right source to get the required information. For example, if the goal is to study customer behavior, data may be retrieved from online transaction records or app usage logs. There are two main types of data retrieval. One is manual retrieval, another one is automated retrieval. Manual retrieval is nothing but collecting data manually through surveys, interviews, or reports. Automated retrieval is using tools or programming languages like Python, SQL, or application programming interface to extract data from database or the internet automatically. When retrieving data, it is important to check the data format and quality. The data should be relevant, complete, and in a usable format like CSV, JSON, or Excel. In some cases, data may be unstructured, such as text or images, and may need special tools to process. Data retrieval is one of the most common methods. SQL is used to extract specific records from database quickly. In web-based projects, application programming interfaces are used to fetch real-time data from websites or online systems. After retrieving the data, it is stored securely for cleaning and further analysis. Retrieving the data is the process of gathering the correct and relevant data needed for a project. It ensures that the analysis is based on accurate, up-to-date, and meaningful information, which leads to better decision and insights. Next is cleaning data. Cleaning data is also called as data pre-processing. Data pre-processing is one of the most important steps in data science process. It means removing errors, missing values, duplicates, and irrelevant information from the collected data to make it accurate and ready for analysis. When data is collected from different sources, it often contains problems such as typing mistakes, blank fields, wrong format, or repeated entries. If we analyze this raw data directly, the result will be wrong or misleading. So, data cleaning ensures that the data is correct, complete, and consistent. There are several common types of data cleaning. First one is handling missing values. Sometimes data has empty or null values. We can fill them with the average value, remove them, or use suitable estimation methods. The second thing is removing duplicates. Repeated records can affect analysis, so duplicates are identified and deleted. The third one is correcting errors. Fix spelling mistakes, wrong data types, or inconsistent formats. Fourth thing is filtering irrelevant data. It's nothing but unnecessary or unrelated information is removed to focus only on the useful facts. And the last one is standardizing data. It converting all values into uniform format. Tools like Python and Excel are commonly used for data cleaning. Clean data is very important because the quality of analysis depends on the quality of data. If the data is clean and accurate, the model built using it will give correct prediction and insights. The data cleaning is the process of preparing raw data into unique, error-free, and usable form that improves the accuracy and reliability of data science results. Next is integrating data. Integrating data is an important step in data science process. It means combining data from multiple sources into a single unified data set for analysis. Since the data often comes from different places like database, website, files, sensors, or application, integration helps bring all things information together in a consistent and organized form. For example, a company may have customer details in one database, sales information in another, and feedback in separate system. To analyze overall performance, all these data sources must be integrated into one data set. This process ensures that every record is complete and represent the full picture. Next is transforming data. Transforming data is an important step in data science process that comes after cleaning, collecting, and integrating data. It means changing the data from its original format into more suitable form for analysis or modeling. The goal is to make the data consistent, organized, and ready to use for machine learning or statistical analysis. When data comes from different sources, it may have different formats, scales, or units. For example, one file may store dates as date, month, year, while another uses month, date, year. In transformation, all data is converted into a common format. This ensures that the analysis produces correct and meaningful results. There are several common data transformation methods. First one is normalization. It's nothing but adjusting values to a common scale, usually between 0 and 1, so that large numbers do not dominate smaller ones. The second thing is standardization. It converting data in to have a mean of 0 and standard deviation of 1. It is useful for statistical models. Third one is encoding. It converting text into numeric form for machine learning. The fourth one is aggregation. It's nothing but summarizing data such as finding total, average, or counts. Fifth one is filtering and sorting. Keeping only the required data and arranging it in a meaningful order. Data transformation helps improve data quality, maintain consistency, and increase the accuracy of results. Without transformation, data might be incomplete, inconsistent, or unsuitable for models. Next, build the models. After collecting, cleaning, integrating, and transforming data, the next step is to create model that can analyze the data and make predictions or decisions. A model is a mathematical or computational representation of a real-world problem. It learns patterns from the existing data and uses that knowledge to predict outcomes on new data. The process of building model is called model training. There are different types of models used in data science depending on the problem. The first one is regression model. It is used for predicting continuous values. And then classification models. It is used to categorize data. The third one is clustering model. It is used to group similar data points. The final one is deep learning models. It is used for complex tasks like image recognition, speech, or natural language processing. Next is steps to build a model. It includes selecting the right algorithm like linear regression, decision tree, random forest, or neural network, and then training the model using a part of the data set and testing and validating the model with another part of data set to check its accuracy. The last one is optimizing the model by adjusting parameters to improve performance. Next is presenting and building applications. Presenting and building application is the final stage of data science process. After collecting, cleaning, analyzing, and modeling the data, the result and insights need to be shared in a clear and meaningful way so that others can understand and use them. This step helps turn data insights into real world actions and solutions. Data scientists use charts, graphs, dashboards, and reports to explain what the data reveals. Visualization tools like Power BI, Excel, and Python libraries make it easy to display patterns, trends, and predictions in, in a simple and understandable format. A good presentation tells a clear story, what the problem was and what action should be taken. After presenting the result, the next step is building applications based on the model or analysis. This means turning the data science solution into a usable product or system. For example, a trained model that predicts customer churn can be built into a web or mobile app that alerts companies when a customer is likely to leave. Similar recommendation models are used in e-commerce sites to suggest product to users. Developers use programming languages like Java, Python, or JavaScript along with frameworks and build these data-driven applications. Next is difference between data science and information science. Data science mainly focus on extracting knowledge and insights from large amount of raw data using statistical methods, programming, and machine learning. It helps to understand patterns, make predictions, and support decision making. Data scientists work on data collection, cleaning, analysis, and model building to create smart solutions. For example, predicting sales, detecting frauds, or recommending products. And information science deals with organizing, storing, retrieving, and managing information efficiently. It focuses on how data is structured, shared, and used within organization. Information scientists design systems such as database, information retrieval systems, and data storage methods to make data easily available and useful. The relationship between the two methods share shared goal, turning data into meaningful information. Information science provides the framework and structure for managing data, while data science applies analytical and computational techniques to find insights from that data. Without proper information organization, data scientists cannot easily access or use data. Similarly, without data analysis organized, information cannot produce deeper insights. Together, they form a stronger connection Information science prepares data for use, and data science transforms it into knowledge. Both are essential for modern technology, research, and business, helping organizations make data-driven and informed decisions. Next, roles and responsibilities of a data scientist. A data scientist play a key role in today's data-driven world. Their main responsibility is to analyze large amount of data to find useful insights that help organizations make smart decisions. Data scientists combine skills in programming, statistics, and domain knowledge to solve complex business problems. The role of a data scientist includes data collection, data cleaning, data analysis, model building, data visualization, and communication. Data collection is nothing but gathering data from different sources such as database, application programming interface, or sensors. And then data cleaning. It is nothing but removing errors, duplicates, or missing values to make data accurate and ready for analysis. The third one is data analysis, studying the data using statistical and mathematical techniques to discover trends and patterns. The fourth one is model building, creating predictive models using algorithms like regression, decision trees, or neural network to forecast outcomes. And the fifth one is data visualization. It's nothing but presenting data and results in the form of charts, graphs, or dashboards using tools like Power BI or Python libraries. The last one is communication, explaining the results clearly to non-technical people such as managers or clients to help them make better business decisions. The responsibilities also include understanding the business problem and defining the right goals, selecting the best tool, techniques, and algorithm for analysis, and then testing and improving model performance for accuracy, maintaining data privacy, and following ethical guidelines, working closely with the data engineers, analysts, and business teams. A data scientist is a problem solver who turns raw data into meaningful insights. Their work helps in improving customer experience, increasing sales, reducing risk, and supporting decision making in various industries like healthcare, finance, retail, and technology. Thank you.